we can just get started with what were we talking about? I think, how did this come up? Somebody, I think it was Cody, shared the Grug. Was it
Mm-hmm.
Yeah, the Grug Brained Developer. I did share that.
Grug Brain? And then I saw the Grug on microservices, which just amused me. Um, if no one saw that, I'll just read it out right now because which is I think good whether or not you know what Grug Brain is like, which is in full it is microservices. Grug wonder why big brain take hardest problem, factoring system correctly, and introduce network call to. Seem very confusing to Grug. So yeah, it's a whole thing. Um, and you seemed interested in that, Casey.
Mm-hmm.
Talk about some architecture deal.
Yeah.
Like, when are microservices good? Do you have an answer to that?
Well, yeah, it's an interesting question. I feel like it's one of those things that so I don't have anything prepared for this, by the way. I do have a couple of
Hot takes.
I do have a couple little demo things that I can show from the project that I'm on at work. I might ask those to get clipped out of any recordings that get shared, just
Oh,
because.
I think uh, not to interrupt, but I am going to interrupt. Um, do you see at the bottom of the screen? There's like some controls. You have like the
Mhm.
mic cam speaker. Do you see a button that says mark clip?
Yeah, who's
Okay.
that?
Yeah, so you can. I just want to make sure anyone can do that. I think, and that's
Sounds
like
cool.
it just puts a marker down so that when you're checking it out, you know, later, then like one of us, like Amanda, me, Jim, whatever, can see those markers, and it'll be really easy for us to find
Oh,
and
nice.
do anything with, like cut it out.
I'm into this app so far. I'm liking it. That's a
Yeah, you
nice
got to thank
feature.
Jim for that.
Yeah, it's cool.
Not
I
that
don't.
Jim made this. I think
Nice work, Jim.
yeah, he found it somehow and told us about it. So
Mm-hmm. Yeah, it seems really useful for like, I mean, exactly what we're doing, or like podcast stuff or whatever.
yeah.
Because I know people are always like marking timestamps when they're recording.
Maybe you can sign up for this and change the way you're doing your streaming for the rest of the week and a half or whatever.
No, I already invested half an
Yeah,
hour into figuring out where all the buttons are on OBS, and that's all I'm willing to spend for the purposes of this jam.
yeah. So back to what you were saying, we could also cut all this stuff out. So if we have a recording of this, no one has to hear us talk about how it works.
Nice. Yeah. So anyway, yeah, microservices is an interesting topic. I think it's one of those things. It's one of those trends in software, right? Where someone developed the technique out of necessity, and then wrote some white papers about it or something. I don't know exactly the specific origins, but sort of like a lot of things in programming, it became over applied. I think it became trendy to do it, and it became it's one of those things where it's an interesting and challenging technical problem to get a whole fleet of microservices working together to present a single system. And a lot of programmers are working on like business domains that are maybe not as interesting as they would like. And so I feel like there is some implementations of microservices are the result of developers trying to create more complicated problems for themselves because that's more fun, as opposed to just directly solving the business problem that's in front of them. So I think that's I think that's kind of what the Grug Brained Developer thing is getting at, is like you don't have to look very far to find uh, a shop that is doing sort of a microservices kind of approach that probably didn't need it, probably could have just gotten by with, I don't know, why don't we just spin up a second Rails server to deal with all of this?
Yeah, yeah.
And
That's so. I guess the question maybe to tackle or to think about is not like when are microservices good in the real world, right? Is, someone thought this up, wrote a white paper. Theoretically, what what are the advantages? Like, why use microservices? Um, and you mentioned something about spinning up another Rails server, right? There's We can get into the whole scaling, vertical and horizontal, etc. Um, but yeah, and I'm not. This isn't even necessarily a Socratic method, you know, fancy like let's tease this out, and I'm pretending I don't know. I'm not sure. Like what it was in the original white paper, or theoretically, what are the advantages of microservices?
Yeah, I mean, I think there's the social slash political uh, advertised benefits, and then there's the technical advertised benefits. And I think, from a social standpoint, I mean, I guess you can go find some early writings from Steve Yegi about how they were approaching this at Amazon. Uh, and there was sort of this decree, and this is kind of, I think my understanding is pretty fuzzy on this, but I think this is like part of the genesis of AWS, or at least some factor in the history of AWS becoming such a juggernaut. But like, there was this decree that every team in Amazon that was working on something had to expose their data and their services through I don't know, like probably not a REST API, but some kind of API that was consumable via the network by other teams. And for an enormous company, or a huge tech team or whatever, I think there's a lot to be said for that. Of like, we've got our own. There's like 5 people working on this part of the software, and we can kind of just do things our own way. We don't have to follow the exact same habits of the 3,000 other developers working on this whole system. We can just function, 5 people can talk to each other and be productive, but 5,000 people cannot talk to each other, because it's just too many connections.
So
So
this
if
is
we
kind
work
of
on
like Conway's law, but like the
it,
positive side of it, right?
exactly. Well, I mean, it's I think it's just a neutral
Yeah,
outcome of Conway's law, is
yeah,
that you have a whole bunch of people, and they are all ostensibly working towards, if not the same business goal, at least compatible business goals, or ones that work in some way together, or are overlapping. I guess overlapping is probably the best word for that.
yeah.
But like, we solved the problem over here of, I don't know, running backlog inventory counts or something like that. A lot of other parts of the system care about that, so we're just gonna, rather than make that like a library that you have to compile into your, like, download and compile into your part of the code, we're just gonna run it however we want to run it, but expose it on the network, and you can use our JSON API or gRPC or whatever you want to do. And I think that makes a lot of sense. I don't know how else you can possibly manage that many people working together than to have each team be like, okay, if anybody else wants the stuff that we're doing, we've stood up a little service and they can get at it that way. And I think that's sort of just almost a social necessity when you're in a huge shop. There's also the technical side of it, which is, theoretically, different parts of your system are going to see higher load or consume more resources to do their job or whatever. And so, like, the canonical example is like, sending emails, or like, running these long running jobs that have to happen every so often, but aren't necessarily going to scale at the same rate as other parts of the system. So like, everybody wants to see the homepage of Twitter. So there's like one main feed that sees really heavy load, but how often do people want to, I don't know, download an archive of all their posts? That happens a lot less frequently. So we can factor out the system into, different services that are running at different, amounts, different strengths. So like, we've got a bajillion different servers hosting the homepage, and then like 2 or 3 little job servers that can take care of those less frequent things. So that's like, the the technical theory. What I think happens in a lot of shops is they don't really need to factor out their system into such a like hard network separation. They're like, oh well, we have all these different services for auth and for sending emails and yada yada, and actually maybe their total traffic load is small enough that a couple of Rails servers that run almost the whole app, and then like I don't know, a couple task runners that can pick up some of those slower things, but like just in a generic way, like maybe that's enough. But you've accidentally made yourself a huge mess of microservices by deciding to try to factor things in this more complicated, huge team way.
Yeah. That's I'm gonna let Jim back in because he has a question that's interesting. Also, I don't know if anybody can see this but the host. Probably not.
It's Jim.
Jim.
Hello. Yeah, no, that was a good overview, Casey. And I think, so my question was, how do we think the economy in the early 2000s, first couple of decades of the 2000s, played a role in the development and adoption of microservices? And I asked that very leading question, and now we'll answer it.
Oh, this
Nice.
is a new way to do a call-in show. I love it.
But I think that Casey, you just ended what you were saying by saying that then you have all these services, and I think that the whole goal of the last couple of decades in software development was to gain market share as quickly as possible, do things as fast as possible, go fast, break things, and I think a lot of people wound up in situations where it was easier to parallelize work than to find ways to make people work together collaboratively. And so I think that it is, if I am just this little black box and I have 2 inputs and 2 outputs, and I can just get plugged into another service, then it doesn't matter, the rest of the system that I'm plugged into, in theory. And lots of things work in theory.
Yeah.
And it feels like, we today, I think that those assumptions have changed and people are being asked to do a lot more with a lot less. And while microservices are still a very valuable pattern and technique, I think that it probably makes a lot less sense for a lot of people. I think it was Robbie Russell from Planet Argon that shared recently, if you're not willing to hire 4 people, maybe don't split your system into a front end framework and a back end framework that have to communicate, and then you have to orchestrate all those people, and you've got to have DevOps involved. And so that was my 2 cents.
Yeah, I like that a lot. I think that makes a lot of sense, the economic factor of it. And you kind of touch on this, Jim, but just to say it explicitly, I think, I mean, I don't know anything about any other business besides software, so I don't know if this is true elsewhere or not. I bet it is. What we say we want to be doing and what we are actually in material reality achieving may not necessarily be the same thing. So, you described that sort of like, it's easy to draw it on a whiteboard, right? Like we've got X amount of dollars from venture capitalists and we need to grow by Y% this year in order to make them happy. So we're going to hire Z developers because having that many developers is going to make us go faster, and draw some boxes and some arrows on a whiteboard, and it's like, look, this team of 10 people is going to do this thing at the same time, this team of 10 people is going to do this thing at the same time, this team is going to do this thing. And easy as drawing an arrow, we just connect them.
Yeah.
We've moved so much faster than we would have with a smaller team. That may be true sometimes, but it's not necessarily true just because you've decided to approach the problem that way.
Yeah.
And I think a lot of people wind up kind of fooling themselves into believing that this is like the fastest way to move. Maybe it is,
Yeah.
but it's not a guarantee.
I want to jump in there real quick, because I had a visualization as you were talking about that, is like, yes, we're all gonna, these 10 people are gonna move, and then these 10 people are gonna move, and then eventually you're gonna have to to merge those you're going to have to integrate those people into the same stream. And the idea of, going down the interstate, do you want to merge one bus or do you want to merge 20 cars? One is a lot more chaotic, and one is, you've got one person who's kind of managing that merging for each vehicle on the bus side.
Yeah, it's also gets into like how you're tracking progress and how you're showing it off. And if you want to show off, like, oh yeah, look, we all these initiatives, these sub projects are moving so quickly, and look, they're all at the end. And then okay, but how do you integrate them all together? Like, let's not talk about that. Or that's where we'll be silent for a while. Um, there's some things that I wanted to say, but Chris had something in chat that I don't know if I fully understand. The Are microservices a zero interest rate phenomenon?
What's fascinating is that I looked up ZERP before I jumped in, because I think that it is like the idea that labor is cheap, and so we'll just use a lot of it, and then because we have labor, we'll be able to do more work. I think it is. I think the popularization of microservices, again, it's a valid approach. It's a valuable technique for various situations, but I think the explosion of microservices was a zero interest rate phenomenon.
I think that seems right.
Yeah, I'm just gonna plop that real quick. So yeah, some of the stuff that I was thinking about with all that sort of history and overview of microservices is that it sounds very related to the DDD idea of bounded context and uh, sorry, domain driven design. And I would grab a book, but as you can see, my shelves are empty. I'm in the process of moving. I have basically all my books backed up. Um, but yeah, the bounded context. Oh, maybe Casey is doing this for us. Um, and yeah, the bounded context is kind of what
Look
it
at that
sounds
cover.
like, right? Oh, I love that cover. That's
Oh.
a Kandinsky. I forget the name of the actual piece, but I know the artist. Not personally, but uh, but yeah, a bounded context is kind of what it sounds like, and I can drop some links in chat as well. But it's kind of like, here's sort of, you think the idea of like, you're laying out everything and you have the boxes of the individual bits, and like you just draw a box around one. Like this is, as an example, like this is the interest rate calculator piece of this whole financial software. This is the authentication piece of all this, and then um, you have the inputs and outputs, and it's black box or whatever. And there's a lot of really good stuff about that, right? And there's a way to enforce it, which is like making completely separate services and doing it like at an ops level, and not allowing anything the ability to reach inside, right? Um, or you can do it more as like a social level, or like a less like a less onerous, or a less like words, less strict sort of boundary. And a lot of things we see, it it's not just like microservice monolith, right? Um, that kind of split, because you can have a big project, a big repo, a big whatever, and then you can have like these packages built in it, right? In the same sort of sense of like, you don't have to rebuild auth systems or whatever. You can pull in a package, a gem. I think in Python, what is it called? Eggs or something stupid. Um, like gem is not stupid, whatever. And just use the normal interface without trying to reach in if you have the ability. Uh, you can do the same thing like in your one project, in your one app, and just be like, this part, this is the bounded context, and you don't reach it, right? And then you can do some things to enforce that, maybe Rubocop or whatever. I'm going to keep talking about Ruby things because that's what I know. But like, there's a little more trust involved there. There's a little more like, I hope I don't screw this up, as opposed to with a completely separate service. You know, you just you can't get there. But there is less orchestration involved because it's all in one code base. You know, you don't have to try to if you make changes, you can make sweeping changes in like a single PR or something and not have to worry about, okay, well, we have a new version of service A and a new version of service B, and they talk to each other. And like, we have to figure out a way to get them both up because it's possibly a breaking change. And hate it. Hate it.
Yeah. I think there's a real, the whole DDD thing. I feel like going from DDD expressed within a program that runs on one computer, but achieves those boundaries through, like objects or modules or whatever, versus one that's split across many computers on a network. I think we as programmers deal in abstractions so much of the time that we fall for this trap that we set for ourselves of treating two things as equivalent if they can like occupy the same box on a whiteboard, when in fact the concrete difference between them really matters. So like, I can draw two boxes with an arrow between them, and that could represent two objects in the same process talking to each other, or it could represent an API call over a network. And it's the same picture on the whiteboard, but it really matters that that's different. And we sometimes in architecture talks try to treat those as the same, or like even go as far as like, sometimes you'll see a system evolve over time where it's like, well, we built it as a thing running in one process, and now we're taking this chunk and splitting it out into a separate service. And we try to, or we can fall for the trap of trying to treat that calling code as like, it's the same thing. It's not an object boundary anymore. It's a network boundary, but it doesn't matter. It's the same interface. But the concretion really matters. There are some things that we can treat as basically equivalent. Like if we're not writing a real-time system, we can treat, a subclass and a superclass as the same thing. If they implement the same interface, that's fine. But if it's a function call or a network call, that actually is really different.
Yeah, there's something I just pasted in chat, which is the Joel Spolsky, Joel on Software, long ago thing about the law of leaky abstractions. And this, so like I talked about bounded context, and it is, I thought you were going to say like you're treating bounded context as equivalent to other stuff. Um, and I'm like, there's some problems there with, because if you are in the same process or on the same machine or whatever, it's different than actually splitting it up. And going back to sort of the architecture and the load and all that, like there are reasons to split it up and to have, different servers doing different things, and that can be scaled differently. And I have experience from my time at GitHub, and I think everything I'm about to say is totally open and known, but we'll go back and scrub it if I'm wrong. But they have, at a very basic level, and this is totally obvious, like they have sort of three classes of servers, and there's the front ends, the file servers, and the database servers, right? I think if they're going to come at me for saying that, then come on. Like
The cops are on the way.
The most obvious thing, and those are three different things that you want to scale in different ways, right? And especially what you were saying about like the two boxes and the line between could be same process, could be separate. There was a big problem with the original idea of how the front ends got information from the file servers, and it was just basically like looked like anything else, right? Sort of the equivalent of what's the Ruby library where you can just like have open also just take web URLs as well as file things. There's something like that. It's just like the code looks the same. You take a you, you take something that's a variable and you shove it into open, but now it's not a file on your system anymore. It's just like the contents of a web page, and so you're making a network call. You don't know, right? So it's a very similar thing. It's just like, hey, we're getting information about this repo, right? Don't worry about it. But then it turns out like that's really bad when you're separated. When you separate them into machines where there's a network call like hidden between there, and you're scaling up a whole lot. And so there's a lot of, short term, and this goes into like the economic deal and trying to grow fast. Like there's short term band-aids thrown at this, a lot of caching, right? Which is good, but also can hide problems. Uh, but there was a big rewrite of how all the Git operations were done to something where it was very, very clear. Like A, it was more efficient, but B, it was very clear. Like you couldn't just be like, oh, let me grab some information from the file server. It's more like you had to very explicitly go through stuff that was like, you're doing a network call. Think about how you're doing this. Are you doing this on like an index page of a lot of things? Like maybe get this in a big batch of stuff with one call, as opposed to just looping through things and doing a call on each one, right? Um, Very similar to we learn about better querying and fixing n+1 problems for databases, and like that can really get you, because the efficiency when you're doing it locally or when you're doing it on one machine doesn't really matter. But suddenly, like you separate it into microservices or anything with a network call, and it just kills you. Uh, and this also some of my experience with, uh, like I resisted Docker and virtual machines and containerization for a long time, but that's also a really good way to you know keep you in mind of like how you're doing these things, and make sure you're not screwing yourself up, because when you are developing something that has separations like that, but you're doing it locally, then you're like, it's fine, right? Like I'll just grab a file, no problem, right? But if you have those as separate virtual machines or something on your computer that can't communicate, or have some sort of faked lag, then suddenly you realize like, oh, even in local dev, this is horrible. This is a bad idea, and then you don't accidentally do things that seem fine but turn out to be bad.
Yeah. I can show a little demo if we're interested in that.
Oh man, Mark.
Yeah, I'm going to mark clip right here.
Oh, I just did it, but
Oh, you did it.
we'll just put like 20 marks right here.
Just look for the enormous pile of marks, and that will be a place where probably, I mean, I don't mind what the stuff that I say about this can be out, but the actual, like, the screen share, probably not, because I haven't.
Oh, that'll be something for us to experiment with. I don't even know how we're going to do this. Have fun, Amanda.
Yeah. All right. Am I sharing my Safari window?
I don't see it.
Okay. I might need to grant permissions. Oh yeah. Tell Chrome it can do that. Allow it.
This guy. All right. Now we can badmouth Casey while he's out of the room, and we can cut this part out. What's up, Cody, Chris, Amanda, Monish? You have any? You just enjoying the show, or you have something to add?
I'm enjoying the conversation. I think, I haven't worked on much code that's been like split into microservices. So for me, it feels like one of these things that everyone continually tells me is a bad idea. Don't do this. And what I almost want to know is where your system is at when you are starting to be like, you know what, I think this is a good idea. I like want to see that spot where you're convincing a bunch of really smart people that it's like, we got to go down this route, and like finding or seeing where that spot is
Yeah.
that's how I feel.
Maybe some of what Casey's going to show us
Yeah.
will make that clear. And I think some of what we've been talking about, where like there are good things about bounded contexts and about having well-known interfaces, and then you can make the argument that splitting things apart more and on different machines, or with greater barriers, like gives you all those positives in a way that easily you can't easily like sidestep.
Mm-hmm.
And then you either don't think about or don't care about the downsides, or you explicitly play them down because you love your solution so much, right? What's up, Casey? We work with Chrome and Edge. That's
we sure do.
That's what I saw.
The Mac OS quit and reopen dialogue is always lying about the second part of that.
No, it's quit. You're saying to quit, and then you'll reopen it.
Right, quit, and then you go reopen.
Yeah.
I was sitting there staring at my computer for like 10 seconds, like, okay, any minute now. And then I realized I accepted that it wasn't going to happen for me, and I had to go do it.
In 5 minutes, it'll like the actual automatic reopen will happen.
I'll have 2 instances of Chrome running, and my computer will just crash. All right.
That happens to me.
It looks like I'm sharing. Oh, yeah, you said you can see the thing.
Yeah.
Yeah. Okay, cool. So I can talk a little bit about the system that I work on at work. Again, probably shouldn't. I haven't like carefully vetted these. The way that it works is we run analysis on file uploads and emails and URLs and stuff like that, looking for a variety of security concerns like phishing attempts, malware, that kind of thing. So it's basically like a security operations team will use the this system to help them move faster, analyzing a bunch of possible security threats and just kind of get information about it. And we run a variety of different analysis tools on things that we get, and what we run depends on the upload, and we can't know ahead of time what we're going to run. So anyway, all that to say, that kind of sets the stage for what we're going to be looking at. I haven't carefully vetted, like anything can pop up in these jobs, company sensitive information, sometimes NSFW stuff pops up. I glanced through these real quick. I didn't see anything that would be like blatantly offensive, but I didn't read every single word on these analysis pages. So I'd rather not share this stuff publicly because I don't know for sure that there's nothing that's not like, sensitive client information or something. I don't think there is, but I'd rather be safe than sorry.
Yeah. Good caveat and stage setting, I think.
Cool. So I'll just kind of run you through an example here. And so anyway, all this to say, this is a demo of what I think is, so I don't have intimate technical knowledge of all of our back-end system stuff. I was hired as a UI specialist. So, I work primarily on the front end for this app. And I dip into some of the back-end stuff as necessary. I'm trying to expand my knowledge of how it all works bit by bit, but my what they're paying me for is mostly JavaScript. So I spend most of my time there. But what I do know about the back-end, I can share. And one of the things that I think is true of it is a microservices architecture that I think makes a lot of sense. So I'll just run you through an example here, and then we can look at a couple already baked ones. We'll just pull them out of the oven ahead of time like a TV chef. So I'm here on the submission page, and what I've just done there, text is probably a little small for you on the screen share, but I've typed a URL into this box, and I'm going to click submit. And what that has done is submitted this job to our job queue. So there's a job dispatcher service that is the first stop past the UI for everything. And as you can see, it's been picked up. We're starting to run. And what's happened here is we've taken our entry point resource, which was example.com, since that's what I typed in, and we've said, oh, what is this? Well, it's a URL. Okay, well, there's a couple of things that we like to run on URLs. One of those is URL reputation. So there are some services out there like urlscan.io that have databases of reputations for different URLs. So like, if you go to, I don't know, malware.ru or whatever, that probably has a URL reputation that you can learn about. Like someone else has already you can trust that source of information about like, is this a dangerous URL or is it benign or whatever? So as you can see, we give scores. Lower is safer. And urlscan.io says there's nothing to worry about from example.com. And, my own professional opinion is that is correct. Another thing that's happening here is Web Analyzer is running. And as you can see, that's been running for a while. So URL reputation came back really fast. That's just a couple of API calls to a remote service that I think is just consulting a database and giving us back whatever it's got in there. Web Analyzer is doing something more complicated. It's actually spinning up like a headless browser and running through some checks there. And what are those checks? We've kind of defined those and refined them over time. But as you can see, it's taking a while. And I don't know how quick it'll come back. This is our staging environment, so things are a little slower because we're a little under provisioned there as compared to production. But we're gonna get some information back from this, and crucially, we never know ahead of time what we need to do. So let me show you another job that's run. This is someone has uploaded an exe file, an executable file. So if we look through this sidebar here, this is the list of all the tasks that ran. And Web Analyzer, like we saw over here, doesn't appear here because we never tried to load a web page. We just had this executable file. So the first thing that we ran on that was this, just reloading for staging here, this static file analysis task. This ran, and it does some stuff like pulls out metadata from the file, gets some other stuff. I don't know what these two things are, but we're running some different analyses on this and just finding some information about what it's doing, and then doing some other things like actually loading this up in a virtual machine, a sandboxed virtual machine running Windows 10, and saying, what happens if I double click on this? And then we capture a bunch of information about that too. So you can see even here, we're like, here's some screenshots of what happens when you execute that file. It looks like in this case, that executable file also involved either it created this file or it contained it within the bundle or something. Somehow it also created this other resource, temp whatever .bat. And we did some things on that too. So we ran this different job, which is slightly different from static file, called static doc. We also ran static file. We also ran it through a sandbox to see what we could find out about it, and a couple other things. ClamAV is like an antivirus software. So we did all these things.
It's interesting. It's interesting that like there's the Windows 7 and the Windows 10 sandbox.
Mm-hmm.
But
yeah,
the bat file only got the Windows 7.
Right. Yeah, that's a great observation. And why did the bat file only get Windows 7 as opposed to Windows 10? I can't tell you off the top of my head. But the system made that decision based on whatever it was seeing. For some reason, it thought, well, we don't need to do Windows 10 on this file, just Windows 7. And I'll just show you one more example here. Here is an email that got forwarded in. This is a .email file. So this one built out, we always build this tree. Sometimes it doesn't really look like anything, and sometimes it gets a little more complicated. So this tree up here is the resource tree that gets generated based on what we find as we analyze the things. So we started with the root of the tree. It was an email file. And it looks like there were a couple of attachments. So there was this docx file. Just reloading the dev environment. There was this docx file, another docx file. These were both attached to that email as just like regular email attachments. And the email content also looks like it contained some links to web pages. So what did we do? We ran email analyzer on that first thing. That's the thing that spawned these other tasks. We ran our static doc and static file analyses on these attachments. And we ran web analyzer, like you saw running for myexample.com, on the links that got sent in. So, what do we get here? So here's a screenshot of that web page, and we look at a couple other things. Like we noticed that there's a form on that web page that collects an email address if you fill it out, that sort of thing.
Could you do me a favor and go back to the URL, like the first tab you showed us?
Yeah.
That's web analyzer and URL reputation.
Mm-hmm.
So, and on these, it's only doing web analyzer and not URL reputation.
Yeah, looks like. So that's also an interesting observation. It may be the case that we only run URL rep if it's like the root node. Like maybe we only check that for the submission, the direct submissions, as opposed to transitive resources, that sort of thing. So anyway, all that to say, so I'll stop the share. I think you kind of get the idea. Again, there's a lot of text. It's a pretty dense UI. There's a lot of stuff going on there. But I think you kind of get the overflow, or the overall flow there. Basically, we get a resource. There's one entry point for the resource. It could be a URL, a file, like an email, a zip file, basically anything. And that job dispatcher decides what to do with it. And each of those other analyses may spawn other analyses of the same type or of a different type. And each of those analysis types is a different, like, they're all different in nature. So like the Windows 10 sandbox, that's a virtual machine. It takes time to spin up a virtual machine. It's pretty compute intensive. Like it's costly to run a virtual machine. So we have, provisioned that service at a certain level that we think makes sense, based on how often it's in demand and how costly it is for us to run and how slow it is and all that stuff. And then, comparing that with the value of the information that we can get from running that. Some of the other things, like you saw the URL rep, that's almost instant, pretty quick, very low cost to run that. That may even be like an AWS Lambda function. I'm not totally sure off the top of my head, but it doesn't necessarily need to be this like fleet of images standing by. And we need different amounts of those things based on how many customers we have, what kind of thing we're getting as submissions, time of day. Like most of our customers are in America. And so like during business hours, there's a lot more demand for the sandboxes than overnight and that sort of thing. So anyway, our team is small. There's like, 6 or 7 of us, something like that. And so we didn't build, I say we, I arrived after all this architecture was created. The team didn't make this choice for social reasons. It's a small team. They can just talk to each other. They don't need to deal with hundreds of people trying to coordinate. I lost my mark clip button, but I'm done screen sharing now.
I marked when we were done.
But I think, in my opinion, this is exactly the kind of technical situation where a microservices architecture makes perfect sense. And in fact, I don't know how else you would do it. I don't think you could reasonably expect to build a system like this in a like single Rails server, basically, or like it would be, you would be waiting a really long time for anything to happen if you did it that way.
Yeah, it's interesting too, because I still feel, and I could be wrong, like microservices is maybe interesting or not quite right way to describe this, or maybe it's just there's lots of things you can do with microservices and you shouldn't conflate them all. Because there's definitely a difference between the idea of microservices and there's network calls going on all the time to get anything done. You're just shooting messages back and forth, right? And then this, which is like background job running deal, which is, and collecting results, which is, there's a great reason to do this. And depending on how you do it, you're talking about like the static file analysis and the URL reputation, right? You can have some things that are like, oh, these don't go in the job because it's so quick, or you're just like, everything goes in the job. It's just easier, right? And some jobs are super quick. And maybe we're adding a little bit of time for the whole job and queuing structure, like all that infrastructure, but like it's easier just to treat everything the same way.
Mm-hmm. Yeah, I think that's a great observation. Yeah. This is crucially not a situation where all of those things are exactly as you observed. It's fan out and then they generate a whole bunch of data, but that data gets collected in a central place, and then the UI only reads that data from one place. Like we're dumping a bunch of JSON
Yeah.
G-zipped up into S3 pretty much, and like that's where the UI gets it from. It doesn't have to get responses from all of those. And like, you know, the in progress job that you saw, that service is reporting its status back to that one-stop shop job dispatcher,
Yeah.
which is where the UI gets its info from. So it is not, it's not all these services collaborating for what the user is seeing in real time. It's fan out, do a bunch of work, then aggregate it, and then the user looks at it, which I think that's like, you know, that's kind of the ideal situation for jobs like that, or for you know, services like this.
Yeah. It also looks like you get again, maybe not you because you're the UI guy that came after a lot of stuff was done, but like you as in that team are doing the harder version of that, which is like fan out, and then maybe some of those things fan out more, and then that's just like more. I mean, just like sending a job and saying like, "Cool, I did it," right? Is the easy way, and then like tracking uh, tracking how long that job takes, getting the status, whatever, gets a little harder. Doing it with multiple jobs and you're waiting for them all to finish so you can report total status. And then when you start having some jobs in queue other ones, whether it's just like in queuing one after or more fan out, and it gets interesting. It gets a little funky. I don't think anyone has done this for, as you were saying earlier, it's more fun, right? It's like no, this is basically I hesitate to say, but like the correct way to handle that. Otherwise, you're just staring for a long time to get any information at all. Um, and also, it gets into like you mentioned like AWS Lambda, like in the scaling. And this is also kind of the promise for all the, was it EC2? I haven't thought about it for so long, where you can have sort of like a fleet of something's ready because it takes some time to spin up and tear down. But you can also, if you do this well, you can be like, oh, we have unexpected traffic, and then just like spin up a whole bunch more to take care of those spikes rather than just like queue everything and say, sorry, I'll let you know about your attack in 3 hours.
Go get lunch.
Yeah, hope you're not too worried about analyzing this quickly. But yeah, that is I don't know, and like I might have not been clear at the very beginning. This I could have been more clear, like the way I feel about our CSS friend that I can't remember the name of it right now. Tailwind. That like I'm not a fan, right? Like I'm not a fan of microservices. I could have been clear from the beginning. And like this, not a fan of microservices. Huge fan of background jobs and fanning out and getting stuff done. And now I feel almost a little conflicted, right? Are they both microservices? Right? Do I have to think about the conflation of this term? And it really depends on how you use them, or what? Casey, what have you done to me?
Yeah, that's interesting. Yeah, I hadn't really thought about that distinction, but it's a critical one, isn't it? The distinction between we have all these little guys talking to each other, and they all have to communicate successfully in order for real-time user interaction to succeed, as opposed to, you know, the real-time user interaction is kind of segmented off in this one little area, and then all the other little guys talking to each other, like that's over here, and them succeeding or failing at that doesn't result in catastrophic failure for the user. Does that distinction feed into the definition? I don't know off the top of my head.
Yeah,
Probably you would get different people defining it differently.
but I think it's really good to see, like, let's say they're all the same, right? Let's just, for this argument, is are microservices good or bad? Are they helpful more than hurtful? It's sort of like, how complicated are they? And just think about, what is the communication pattern, right? If it is like a full, complete graph, like a total mesh of everything talking to everything, don't, right? Like that just gets real bad real quick, right? Um, is it, a bunch are sort of interconnected, but, and for interconnected, also read or hear interdependent, right? Are there a whole bunch, but there's kind of like a few things back and forth? Not as bad, right? But maybe not great either. Is it like this, where it's all like fanned out and it's all feeding backwards, right?
Yeah, it's
Then
really almost a
that
tree.
yeah, that's like the easiest thing possible. The only thing easier is you just fan out and say like, well, I don't care about you. You do your job or not.
Yeah, maybe you
We'll
sent
find
that
out.
email. I don't care.
Yeah, right. Or maybe I get some information, but it's not feeding back. It's like written to a log file, and I have to check the log file later.
Mhm.
And so, yeah, I think maybe that's what it comes down to: is what is the interdependence and the communication necessary. We solved it.
Did it.
We know what microservices are good or bad for.
Time to write the blog post that changes
Yeah.
the world.
Yeah, draw out your graph and then just see how sad it makes you.
I feel like I heard, are microservices a good idea? It depends.
Cody,
Maybe.
I mean,
That's it.
here we are. Monish, I don't know how much you know about all this in general, and especially us, but we joke, sort of haha, only serious, that the answer is always it depends.
It's pretty much always it
It
depends.
it comes back to it depends, no matter what.
I get
Might be.
context is king, is what sometimes people say. And there's actually a book written called It Depends recently that I got to know about. It's by,
Did we write this book? Hold on, I'm gonna find a link.
I think it's by this person called Kevin Goldsmith. He's a CTO at a company. And I think, yeah, it makes sense. It does depend. I mean, Shopify uses bounded context, and they don't use microservices. The company I currently work for, they use Packwalk and bounded context, and we don't use microservices, and it works for them. So it does depend.
That's great. I don't know if we can wrap it up any better than that. So I'm just going to thank you all for being here and being part of this interesting experiment. And maybe we'll continue to use it. We'll find out. We have 2 weeks to figure it out for the next time. Thanks,
Yeah.
everybody. I'm going to
Good
stop
talk to
recording.
y'all.
Make sure to pay attention to the uploading part at the top of your browser. So
Will be.
like and
There's a
subscribe
cat.
or whatever. Oh, I can't stop
Yes.
while we're looking at a cat.
The perfect
can.
ending. What's the cat's name?
That's Otto.
Otto.
He
Oh,
wants lunch.
Nice.
But lunch
I
isn't for
want
another
lunch as well.
90
So
minutes.
This is
cat
perfect.
don't care. Cats
Yeah.
don't care.
All
Bye.
right. Good to talk to y'all.
Bye.